All right, PreCalc, some more trig identities to take a look at here. And sometimes you got to find common denominators with some of these problems. So if we take a look at this guy right here, cotangent plus cosecant all divided by cosecant. All right, what I would do is maybe kind of split this up into two different fractions and say this could be a cotangent divided by a cosecant plus cosecant. And anything divided by itself is really just a 1. So this then turns into a cotangent divided by cosecant plus a 1. And what I would do from here is maybe rewrite these in terms of sines and cosines. So cotangent is really going to be a cosine over a sine over, and a cosecant is a 1 divided by a sine. Don't forget it's always still a plus a 1 over there. All right, and then from here, maybe you can invert and multiply the green stuff, and this is going to be a cosine over a sine times by sine over 1, and you notice that the sines drop out, so you're just left over with a cosine, and then that plus a 1 hanging out. So that's a cosine x plus 1 there. Super. All right, number 2, we got a sine plus cosine cotangent. Again, try to rewrite this in terms of sines and cosines. So this is a sine plus cosine times by cosine over 1. Oh, not cosine over 1, cosine over sine. Well, that cosine is really a cosine over 1, so we can go with sine plus cosine squared over sine. And to combine these two together, you want to get a common denominator. That common denominator is going to be a sine, so you got to multiply top and bottom by sine over sine. And that's going to be sine times sine is sine squared plus cosine squared all over sine. Hey, look what that is. Sine squared plus cosine squared. That's your Pythagorean identity. That's a big old 1. So that's a 1 over sine, which is the reciprocal identity to cosecant theta. Go figure, all that turns into cosecant theta. All right, and then number 3, what you might want to do is try to get a common denominator here. So the second fraction is going to need a cosecant plus 1, and the first fraction is going to need a cosecant minus 1. And when you do that, you might want to turn this into a cosecant minus 1 times by sine, and then that's going to be plus a sine times by cosecant plus 1, and then the denominator there is cosecant plus 1 times cosecant minus 1. Well, that's going to be a cosecant squared minus 1 when you FOIL it out. All right, so a couple things that you notice there. Well, cosecant squared minus 1, that's a Pythagorean identity. Of course it is. That's going to be a tangent square, or a cotangent squared. All right, so that on the bottom is really going to turn into a cotangent squared. Up on the top, if you were to distribute that sign, distribute the sign, cosecant times sine cancels out to be 1. So this is a negative sign. And then if you were to distribute this sign over here, sine times cosecant cancels out to be 1. So that's going to be plus a positive sign, all divided by a cotangent squared. Well, sine minus sine, that's a 1. 1 divided by cotangent squared, that's the reciprocal identity to tangent, or tangent squared. So your final answer there is just going to be a tangent squared, and that is x. Now, one other thing to point out about this problem here is when you distribute cosecant times sine up top in that green part, you really get, it cancels out, but it cancels out because it turns into 1. All right, and then the other part right there is when you distribute this sine times by the cosecant there in blue, it also cancels out, but it cancels out to just be a 1. So the negative sign and the positive sign, they really combine out to be 0. So if you're wondering where I got that 1 from, I didn't actually get a 1, I got a 0, but it's really a 1 plus a 1, which is actually a 2. So this is really a 2 times by tangent squared x. So sorry about the confusion on that one. All right. keep up the good work, and let's see what else we can do. I think the more practice we'll kind of skip over that. And if we kind of go through a couple more of these, again, same exact rules as before. All right, but we might say, let's go with cotangent plus cosecant divided by cosecant. And I think we've already done, yeah, we just did those problems. So let's soup them up a little bit here. How about 1 over sine squared plus secant squared over tangent squared? Well, 1 over sine squared, that's the reciprocal identity to cosecant squared. And then secant squared over tangent squared. What could we do with that? Secant squared over tangent squared. Let's see here. Maybe, just maybe we could get a common denominator here and maybe move that tangent squared here, but I got to multiply the other one by tangent squared as well. All right, what happens then? I've got tangent squared times cosecant squared plus secant squared, all divided by tangent squared. All right, so then maybe to clean some stuff up here, let's maybe see what we can do with this guy right here. How about turning everything into sines and cosines? Maybe. Let's see here. Tangent squared. That's going to be a sine squared over a cosine squared. And cosecant squared. That's going to be a 1 over a sine squared. Oh, okay. I see. Sine squareds cross off. And then I still have plus a secant squared, which would be, well, wait a second, secant squared, isn't that 1 over cosine squared? Which is secant squared and secant squared. So this is a secant squared plus another secant squared, which is a 2 secant squared in this case. And I still want to divide it by that tangent squared, which was in my denominator. So now I just have one fraction, so I don't have to worry about that. Maybe now let's turn things into sines and cosines, see what happens from there. 2, let's see here, secant squared is really, let's see here, 1 divided by cosine squared, and divided by tangent squared, which is sine squared over cosine squared. If I invert and multiply, I'm just gonna move that 2 up top there. 2 divided by cosine squared times by cosine squared over sine squared. Oh, look what happens. The cosine squareds are gone. So this is really 2 divided by sine squared, which is the reciprocal identity of the cosecant squared. And my variable this time was an x. 2 cosecant squared x. Crazy. All right. Moving on to number 2 right here. I've got, let's see here, 1 minus sine x and then a cosine x. So let's try to get a common denominator here. So I got to go 1 minus sine on the top and the bottom of this fraction. And on the other fraction, the first one, I need a cosine over a cosine. And if I go through and multiply some things out, I have cosine times cosine is cosine squared. Minus, if I distribute this negative sign to the first and the second, negative sine, so that's minus a sine x. Negative sine times a negative sine is a positive sine squared, all over cosine times by a 1 minus sine. All right, let's see what we have here. Let's see here. Cosine squared plus sine squared. That's Pythagorean identity. That's 1. So I've got 1 minus sine x divided by cosine times by 1 minus sine x. Ooh, I've got some stuff that crosses off. 1 minus sine x, 1 minus sine x. So I just have 1 over cosine or cosine x, which is the reciprocal to, you guessed it, secant. So that's the secant of x. Fantastic.